Welcome back to the P3 series. Today we're going to talk about the past paper questions for logarithmic and exponential equations, which is according to the syllabus of 9709 P3, that's chapter 2. In books, this may slightly vary, so we'll try out some questions today from 2023. So, starting with the first one, October-November 2023, variant 3.1. And question number 3. So let's see this. Variables x and y are related by the equation y equals to a b raised to power x. Notice that the power is only on the b, not on a. The diagram shows the result of plotting L and y against x for two pairs of values x and y. The coordinates of these points are 1, 3.7, and 2.2, 6.46. Use this information to find the values of a and b. So one thing to notice, these points are not x, y coordinates. These are x, L, and y coordinates. Now, first off, we need to know what's the relationship between x and L and y, because we know what's the relationship between x and y, but we don't know what's the relationship between x and L and y. Until we know that, we are not able to find out how to figure out the value of a and b. So what we do is we use this exponential equation and turn this into a logarithmic equation with the base e, basically ln. So when we have y equals to a b x, we take ln on both sides. We will have ln y equals to ln of a b raised to power x. So ln y remains as it is, but ln a b raised to power x can be separated into ln of a plus x ln of b. This is just simply using the laws of logarithms, nothing else over here. So since a and b are constants, ln of a and ln of b are also simply just constants. So the xy coordinate pairs, in short, this is, let's call it x y prime over here. This is our y prime. This is our c, the y-intercept, and x times by m, that is our gradient. Sorry. So ln of a is our y-intercept. Gradient would be our ln b. So all we need to do is since we have two unknowns, we can reuse these two conditions to figure out what are ln a and what are ln b. So using 1, 3.7, so this equation we are using, not the y a raised to power b. Actually, we could use that also, but we would end up the same way. So 3.7 equals to ln of a plus 1 times by ln of b. Similarly, we have 2.2, 6.46. We could convert them into C and M also. So for example, if we convert them into C and M, that might make it visually a little bit better, but still not that big of a difference. So 6.46 equals to C plus 2.2 times by M. Now we have simultaneous equations. We can solve for C and M, and then we can use them to find out ln A and ln B, and then A and B. I will show you a different way to solve this also, but let's see this first. This is easy to see what we are doing over here because we have two linear equations in C and B, so we just solve them simultaneously the way we know. Subtract these two equations, minus, minus, minus. So we have 3.7 sorry, 3.7 minus 6.46, that is minus 2.76. This cancels out, and 2.2 minus 1 would be just minus 1.2 m. So divided by minus 1.2, that would be just 2.3. Now let's find out the c first also. So c would be just 3.7 minus m. So 3.7 minus 2.3, that would be 1.4. Now, m was ln b, and ln of a was c. So ln of b is 2.3, and ln of a is 1.4. So we just simply reverse the logarithm, take so e raised to power ln b is just b equals to e raised to power 2.3, 9.97, okay, 9.974, and e raised to power ln a is just a equals to e raised to power 1.4, 4.0552. Now, usually we just need it in three significant figures, so we will convert this into three significant figures. So A would be 4.06, and B would be 9.97. And that's about it. Another way we could have solved this is, since we know that the graph is between x and ln y, we could use this to find out the gradient. The gradient would have been 6 point. So we actually just, sorry, my bad. We know that the ln y equals to ln of a plus x ln b. So we know that the gradient would be equal to this. So we find out the gradient, that would be 6.46 minus 3.7 divided by 2.2 minus 1. So that would be 6.46 minus 3.7 divided by 1.2, that would be 2.3. Same thing which we got already. So since we know ln of b is 2.3, we would do the same thing we just did. We'd reverse the ln 2.3, which is exactly the same thing. Once we have found the ln b, which is 2.3, so we will go back to ln y equals to ln of a plus 2.3x. Now we can use any of these, since there's only one unknown left, we can use any of these conditions to find out a. So let's use the first one. So 3.7 equals to ln of a plus 2.3 times by 1, that would be just 2.3. So ln of a would be 3.7 minus 2.3, that is 1.4, and then a would be e raised to power 1.4, and that would give us the same answer we just saw over here. So no need to write the answer again. The process is very straightforward. Okay, all right. So two ways to see the same question. In essence, we had two unknowns, so we needed two different ways of finding A and B, two different conditions. All right, on to the next question. All right. So the next question is from October-November 2023, variant 3.3. Although this looks like a mod question, and partly it is, but we can solve it with the the last few steps would be based on solving the exponential equation. So some part would be mod, some part would be that. Now, find the set of values of x satisfying the inequality 2 raised to power x plus 1 minus 2 less than 0.5. Now, two things we can do. First off, we can bring out this 1 by just simply writing it as 2 times by 2 raised to power x minus 2, 0.5. And that now we can replace 2x with anything. So if, let's suppose a is 2 raised to power x, so we can rewrite this as 2a minus 2, 0.5. The 2 and the 2 over here are not bothering us, so we can keep it as it is. So, two ways we studied how to solve this kind of inequality. Let's use both of them to see we would get the same answer anyway. So first we need to find out the value of a before we go to x. So two ways to find a. One way is to know that 2a minus 2 would be in between minus 0.5 and 0.5. And then we solve this inequality. Plus 2 goes on this side, and plus 2 comes on this side. So we would get 1.5, 2.5, and then we further divide by 2. So 1.5 divided by 2. So that would be 3 by 4, 0.75, and 2.5 divided by 2, that would be 1.25. Now this is just a, not the x. So we will come back to it. Second way of finding the same inequality, a, not 2 raised to power x, sorry, that would be with the squaring method. So that when we square this, square both sides of this, we will get 2a minus 2 whole squared less than 0.5 whole squared. When we take the square on one side, this becomes a difference of squares form. So we can rewrite it as 2a minus 2 plus 0.5 and 2a minus 2 minus 0.5 less than 0. This would become 2a minus 2 plus 0.5 would be minus 1.5, and 2a minus 2.5 less than 0. This is sort of like a quadratic equation where one answer would be one critical point would be 1.5 divided by 2, that is 0.75, and the other one would be 2.5 divided by 2, which is 1.25. Since we want the area less than 0, so that would be in between this, and that is exactly what we had before. So 0.75 less than 2a, no sorry, a, and 1.25. Now, once we have the a, or range of values of a, now we can replace it with 2 raised to power x. So this means that it's the 2 raised to power x that is 1.25 and 0.75. Now, over here, we could take log base 10 also, or we could take ln also. So absolutely no difference. So when we take ln on all sides, ln of 0.75, x, ln 2, ln of 1.25. And then we divide ln 2 on both sides. ln 0.75 divided by ln 2 less than x less than ln 1.25 divided by ln 2. Now we just need to find the values to three significant figures as written. So 0.75, divided by ln of 2. This one is 0.415. And the other one would be 1.25. So 0.322. And that's about it. That's about it. All right, on to the next question. So the next question is May June 23 variant 3.1. Solve the equation 3e raised to power 2x minus 4e raised to power minus 2x equals to 5. And we have to give our answer in 3 decimal places. So what do we do over here? It's very straightforward. We can start off by making e raised to power 2x into something else that would make it slightly easier to solve this. So a would be e raised to power 2x. So that would make it 3a minus 4 minus 2. So basically a raised to power minus 1. So that would become a and equals to 5. We take a, we multiply both sides by a, we would get 3a squared minus 4 equals to 5a. This seems to be a quadratic equation, so 3a squared minus 5a minus 4 equal to 0. So first off, we need to solve for a over here. Let's see if we can factorize this. If we cannot factorize it, we can just simply use the quadratic formula. So the basic sum and product rule, it's not guaranteed that we'll be able to do that, but let's try anyway. So so 3 and 4, 1. So there is no combination of 3 and 4 that can get us. Okay, wait, let's try 2 and 2. Yes. Okay, now we can think about this. So 5. No. 6 and 2, no, definitely no. And no, okay, oh no, we can't factorize this. Okay, so let's just simply use the quadratic formula. So that would be minus b plus minus b squared minus 4ac. That would be plus times by 4 times by 3 times by 4. So 4 times by 12, that would be 48, and minus would become plus square root divided by 2a, 2 times by 3, 6. So 5 plus minus, so square root of 25 plus 48, that would be 73 root divided by 6. We can just simply find the answer, 5 plus answer divided by 6. So one answer is simply this. Since this is not the final answer, let's keep it this way. And the other answer is 5 minus root 73 over 6. Since a was e raised to power 2x, that would mean that this is, we can write it as e raised to power 2x over here. Now we just simply take the ln of both sides. So that would become 2x equals to ln of 5 plus root 73 divided by 6. And 2x would be ln 5 plus minus root 73 divided by 6. Now, ln of answer would be this, and then divide by 2. One answer for x would be 0.407. Now, for the second answer, we go back to the thing, ln 5 minus root 73. Actually, let's see what the value is first. Divided by 6. Now this is coming out to be negative. This will not give us any solution because we cannot take the ln of a negative number. So just see this over here, we will get a math error over here. So this will not give us any solution. So 0.407 is the only solution for this. Now, how do we test this? How do we test this? We go back to actually get this answer. 5 plus 73 ln of answer divided by 2, 407. Okay, now we go back to this equation over here and we subtract it with 5. So this side minus 5, if we get equal to 5, if we get equal to 0, we get the thing. Or if we put x over here in this side, we should get 5. So 3 e raised to power 2 times by answer minus 4 e raised to power minus 2 times by answer. And we get 5. So that means our answer is correct. Okay, all right, on to the next question. Okay, so the next question is also from May-June session, but from variant 3.2. So solve the equation ln 2x squared minus 3 equals to 2 ln x minus ln 2. Okay, so what we do over here is we simplify the ln term. We cannot further expand this, but we can further make it into one ln expression over here. So this becomes ln x squared minus ln 2, and minus could be written as like this, ln 2x squared minus 3. Now using the equality rule over here, if two numbers have logarithms equal to each other, that means those numbers are equal. So that would mean 2x squared minus 3 would be equal to x squared over 2. So we simplify, multiply both sides by 2, we would get 4x squared minus 6 equal to x squared. 6 goes on this side, 3 comes on this side, so this becomes, sorry, x squared comes on this side, 6 goes on the other side, so this would become 3x squared equals to 6, and that would get us x squared equals to 2. Now, when we solve this, just as it is, we would get x equals to plus minus root 2. However, there's a problem over here. If you notice over here, we had the ln x term, not the ln x squared term. If we had the x squared over here, then it was probably fine. But we cannot have the parameter or the argument of the ln or log either 0 or less than 0. So the negative answer would be discarded. So the final answer would be just positive. And that's our answer in the exact form. Now you can test your answer with the same thing. So this time we have two things, like expressions two sides, so we could basically subtract it. Or we could actually do this thing. So we could subtract these two expressions together. If we get 0, that would mean that we are right. The value of x is root 2, and then we do ln 2 answer squared minus 3 brackets minus ln answer squared divided by 2. If the difference comes out to be 0, that means they were equal, and that comes out 0, that means they were equal. All right, good. On to the next question. Okay, so wait, sorry, my bad. This is probably 3-3, sorry, not 3-1, my bad. So this is 3-3, question number 1. So solve the equation. There's give your answer to 3 decimal places. Okay, so ln x plus 5 equals to 5 plus ln x. there are two ways to solve this. One way is to attach an ln term with 5 to make all the expressions ln. So ln x plus 5 is equals to 5 ln of e, because 5 times by 1, ln e is 1, and we can write it like this. Or we can take ln expressions on one side, x plus 5 minus ln of x equals to 5. This would become ln e raised to power 5 plus ln of x. So this could simplify to ln e raised to power 5 multiplied by x. And then what we could do, we could equate the arguments together. So x plus 5 would be equal to e raised to power 5 multiplied by x. So before we simplify, let's see whether we get the same expression or similar expression from the other way also. So when we use the laws of logarithms, we get x plus 5 divided by x equals to 5. When we reverse the ln, this would become x plus 5 over x equals to e raised to power 5. Now, as you can see, they are similar because when we multiply x on the other side, we would have exactly the same thing. Now, what we need is to take x expressions on one side. So 5 equals to e raised to power 5 x. Sorry, no. X e raised to power 5 minus 1. And then finally, x would be 5 over e raised to power 5 minus 1. And this would be the exact answer, but we need the answer in the 3 decimal places. So 5 divided by e raised to power 5 minus 1. So 0.034. And that is our answer. Now, on to the next question. Okay, so February-March 2023, variant 3.2, it is given that x is equal to ln 2y minus 3 minus ln y plus 4. Express y in terms of x. So basically, we need to make y the subject. So first off, what we would do is we would simplify the expression on the right with the help of the rules of logarithms. So we can rewrite it as ln 2y minus 3 over y plus 4 equals to x. Then we reverse the ln, e raised to power x, e raised to power this. We would be left with e raised to power x equals to 2y minus 3, y plus 4. We multiply y plus 4 on the left side, we would have e raised to power x, y plus 4 e raised to power x equals to 2y minus 3. Remember that y is what we need to make the subject, not x. Since we need to make y the subject, so we pull all the y terms on one side, and minus 3 minus 4 e raised to power x. We factorize out the y, so this becomes e raised to power x minus 2, and we can take out the minus over here, minus 3 plus 4 e raised to power x. Next, we make y the subject, so this becomes minus 3 plus 4 e raised to power x divided by e raised to power x minus 2. So what we can do, we can leave it in this form, or we could rewrite it as, we could multiply the minus in the denominator. That could become 2 minus e raised to power x. However, both forms are equally correct, whichever way you want to leave it as. So that's it. That's our final question for the 2023. Hopefully, we will see each other in the next video about the next topic. Don't forget to like and subscribe. And if you feel that I have made a mistake or I have left something that needs a little bit more explanation, please don't forget to write it in the comments. Take care. Bye bye.